Hello everyone. I welcome you all in the next lecture of 12th class NCERT Mathematics. In this lecture, I'll discuss question number 9, 10, 11 and 12 of exercise 1.2. So without further ado, let's get started. The question number 9 is function f defined from n to n, where this n is a natural number set and defined as fn equals to, if n is odd, then n plus 1 upon 2, it provides output n plus 1 upon 2. If n is even, then it will provide n by 2 for all n belongs to natural number. And we need to check state whether, we need to check that it is bijective or not, justify your answer. Okay, so here what they said, function is defined from a set of natural number to a set of natural number, and how they define f of n is equals to n plus 1 by 2 and n by 2, n plus 1 by 2 when, if n is odd, and if n is even, then it is n by 2. Now for 1 1 we need to check. For 1 1, observe that f of 1, if I want to find, then it is lie in the first branch. Actually it is a piecewise function. How it defined? Piecewise. It is a piecewise function. So f of 1, well, we will find by the first piece, 1 plus 1 by 2, and we will get 1. Okay, f of 1 is 1 value. But observe, if I will find f of 2, image of 2 under f, what will be? 2 by 2 equals to 1. So we have 1 is not equal to 2, but f of 1 is equal to the f of 2. So it means that, and there are more same f of 3 and f of 4 do the same thing. We observe that different element of domain set, different element of domain set have same image, it implies that f is not 1 1 function. Okay, now as I give here example, okay, here I give example 4 on 2. You can take another example also. You can take for x1 is 3 you can take, and x2 is 4 you can take, and observe that f of 3 and f of 4 both are same, while 3 and 4 both are unequal. For on 2 we observe that actually here we can observe, if I will put n that is odd, if n equals to 1, 3, 5, 7, 9 up to so on, they will provide all the natural numbers. 1 plus 1 upon 2, that is 1, 3 plus 1 upon 2, that is 2, 5 plus 1 upon 2, that is 3, okay, and 7 plus 1 equal to 4 up to so on. So it means that every corresponding to every odd we will get a natural number 1 2 3 up to so on, and corresponding to even also we will get. Here even are 2, 4, 6, 8 up to so on. So n by 2 is 1, and 4 by 2 is 2, 6 by 2 is 3, 8 by 2 is 4 up to so on. So here and function is defined from where to where? Function is defined from n to n. So what I can do, let y belongs to natural number, that is codomain according to definition. Okay, codomain set. Okay, codomain set. Now f of n equals to y, I'll assume. Okay, and I will try to find here what is the format of n. Okay, so let us suppose, one more thing I need to assume here, n is odd. If n is odd, then we have condition is n plus 1 by 2 y. So what is the format of n equals to the format of format of n will be 2y minus 1. Okay, so here we can observe that n is of the form 2y minus 1. That means for each element from the codomain set, if I am choosing, then we have its preimage that is odd. Okay, and also same thing, let, actually we no need to mention this thing. I'll first case I will take that f of n equal to y, and without loss of generality, I will assume f of n equal to n plus 1 upon 2. So here I am observing that for every natural number we have a preimage that is 2y minus 1. Clear? And here the second case is, because if fn equal to n plus 1 upon 2, maybe someone will come and say, sir, why didn't I assume fn equal to the n by 2? So here also we can do same thing. Y belongs to natural number, that is codomain okay, from the codomain set I took this element. Now fn equal to the y I assume. So in this I assume y, and the formation of n is 2y type. Okay, so here if I am choosing any natural number, then corresponding this y will come corresponding to the even natural number. So it means that, what it means that same number I am choosing for every natural number we have two pre-images. Clear? We have how many pre-image we have? Two pre-images. It means that f is, so that is additional. This is additional. So it means that for every element we have pre-image, it means that the range of f is equal to complete n. And if range is equal to the codomain set, it means that f is onto function. Actually here, in my opinion, there is no need to check onto function. Why so? Because we already proved here that f is not a one-one function. See here. Here I already proved that f is not a one-one function. If f is not a one-one function, then f is not a bijective function. So here we can mention that no, it is not a bijective function, hence proved. If it depends actually on the in how much marks the question came. If it come in 2 or 3 marks, then you can do simply not 1 hence not bijective. But if it will come in 5 marks, then you can play safely. Okay, you can prove both of them, that you need to check 1 as well as on 2, and if one of the condition is fail, either 1 or on 2, then you can say that it is not bijective, because for bijective we know that the function has to be 1 as well as on 2. So I hope you understand this question. Now the next one is, yeah, 10th one. Function, we have set a r minus 3, okay, and b r minus 1. Now consider the function defined from set a to set b, define as like that, and f is 1 1 and on 2 is f is 1 1 on 2 is, we need to check and justify your answer. Okay, so first of all I will check 1 1 and then I will check on 2. Now function is defined, instead of writing a and b, I'll write r minus 3 to r 1. Clear? So how they define function? F of x is defined as x minus 2, x minus 3. Clearly we observe that x not equal to 3. X is not equal to 3. Obviously it is not in the domain, so it is obvious. Now for 1 1, how we can check 1 1 next? Let x1 x2 belongs to set A. Set A we already know, set A is a domain set, R minus 3, and set B is our codomain set, that is r minus 1. Okay, so x1 x2 belongs to A such that f of x1 equals to f of x2. Now what is f of x1? By the definition, x1 minus 2 upon x1 minus 3, and here what we have, x2 minus 2 upon x2 minus 3. Now we need to do cross multiplication, x1 minus 2, x2 minus 3, and here x2 minus 2, x2 minus 2, x1 minus 3. Clear not? Now cross distributive law we need to apply here, x1 x2, okay, x1 x2, what we x1 x2, and then we have minus 3 x1 minus 2 x2 plus 6, and here what we have, this is 3. Okay, so x2 x1 minus 3 x2 minus 2 x1 plus 6. How many things cancel? See, this one and this one cancel, 6 and 6 cancel. Now we need to write here minus 3 x1 and minus 2 x1. I'll take that thing this side and this one this side. So x2 here, x1 here, and they are equal. So it means that f is 1 function from A to B. Okay, now for onto, for onto, for onto let y belongs to B, we need to choose an element such that f of x equal to y, I'll assume. Okay, so what we need to find here, I need to find here the what is the format of x. Clear? And is there any problem if I am taking any element from the set P, is that format is valid? Clear, the first thing. And also if it is valid, we get the value of x, real value of x if we will get, then that value is in the set or not, is in the domain set or not. Okay, so here I'll do, then I'll explain. F of x is, what is our f of x actually? F of x is x minus 2 upon x minus 3. Okay, f of x is x minus 2 upon x minus 3 y. So from here we need to find the value of x in terms of y, y x minus 3. Now x minus 2 yx 3y. So can I take this left side, x I'll take common, 1 minus y, 2 minus 3y. So here what we have, x equals to 3y minus 2 y minus 1. Can I write like that? Okay, now so here y is not equal to 1. For all y not equal to 1, x is defined, x is defined. Clear? So it means that, and already we observed that y is not in the codomain set, y is not in the codomain set, they already remove it. So it means that what we have, f is onto function. If f is onto function, implies f is bijective function, f is bijective function. I hope you understand this question also. So move on to next question. What is our next question is, yeah, this is our next question. I'll change the color. Yeah, here what we have, wait. Yeah, function is defined from R to R, f of x equal to x raised to power 4. Choose the correct answer. We need to tell which one is the correct. F is 1 on 2, that is f is bijective. A implies, and B is f is many one and onto function, okay, and f is one but not onto, and f is neither one nor onto, okay. So first of all, I'll draw the graph, or by the graph I will explain it, and by mathematical method I will also explain, okay, analytical method. One is analytical method, one is graphical method. So the first I will explain by the graphical method because it is a very short way. It is MCQ actually, okay. It is a MCQ. So it may be come in 5 marks also. Then we need to use analytical method, okay. Now here we can observe function is defined from R to R, okay, and f of x is x raised to the power 4. We observe that the power, this power is even. This power is even power. If it is even power, it means that the value is has to be greater than equal to 0. And the graph of this function is like that. See, like that we have, okay. So it means that the what is the range? Range of f is close 0 to infinity, because it provides always non-negative values. So it means that the range of f not equal to complete R, that is codomain, implies f is not onto. Also we can observe here that f is not 1 1. Why so? Because f of 1, f of minus 1 both are equal, but 1 is not equal to minus 1. Clear? So here f is not 1 1, implies that D is the correct answer. And analytical method is this is a graphical method, I can say. In analytical method, I need to assume that for 1 1, what I need to do, let x1 comma x2 belongs to real number, okay. So and such that I need to assume that such that f of x1 equals to f of x2. So what is f of x1? That is x1 is to the power 4, and here x2 is to the power 4. Can I take it left side? X1 is to the power 4, x2 is to the power 4 equal to 0. So here what we have, x1 minus x2, x1 plus x2, and here x1 square plus x2 square. Actually we will write like that, x1 square to the power square minus x2 square the whole power 2 equal to 0, a square minus b square formula, okay. So here we can observe this thing is never 0, okay, because these are positive terms. So we have two conditions, either x1 equal to x2 or x1 equals to minus x2. So here we have some problem in this case. Why so? Because if I assume x1 equals to 2, then x2 has to be minus 2, okay. And we observe that f of 2 is, what is f of 2? 2 raised to the power 4. F of minus 2 is also 2 raised to the power 4. So we observe that here outputs are same, but their inputs are different. So it means that different element have same image. F is not 1 1, okay. And for onto we can write the same thing. For onto we can write the same thing. Clear? From start, I'll write here. Wait, I'll write here. Wait. It's 12 question. Yeah, I'll write here. For onto, we have for any y belongs to R, okay. Not for any y. Let us, I need to choose for y. What we have? Let y belongs to R, okay. So f of x equals to y, and what we have, x power 4 equal to y. So as x power 4 is greater than equal to 0, it implies that y also has to be greater than equal to 0. It means that only the y has to be non-negative. So for the negative we don't have pre-image, and we can write the same line. this same line we need to write here, these three lines, and hence f is not on 2. So the option is D, f is neither on 1 nor on 2. I hope you understand this question. Now the next question is function defined from R to 1 f x equal to 3x. It actually is very easy, you can do, that's your homework. Okay, that's a very easy question, you can easily prove. One is very easy. You can assume x1 x2 two elements and f of x1 equal to f of x2, then you can prove that x1 equal to x2. For on 2 you need to assume let y belongs to this codomain set and f of x equal to y, and find the value of x in terms of y. I'll not do this thing, you need to do, and if you have any problem then you can inform me in the comment box. So thank you for watching.